This problem and all other CALC 152 problems can be found here at Sarai Studies. Link is in the description box below. Does the following sequence converge or diverge? If it converges, what does it converge to? All we have to do is just take the limit of the sequence as the numbers in the sequence go on forever. And so as soon as we see something raised to an exponent, we want to get rid of that exponent, and that goes back to our CALC 1 skills where we utilize our property of logs. So we know that if we have log of something and it's raised to that exponent, we can just pull that to the front. But then the problem is this isn't a log. But the question is, well, how can we make it a log? Well, we're going to let L be equal to this limit, and then we're just simply going to take log of L, and then whatever we do to one side, we have to do to the other side as well. So we're just taking log of this stuff in here, and then log of this is really just the limit of ln of this stuff. So just do a switcheroo, and then you can get rid of your parentheses. Now that you have ln of something raised to the exponent, you can just take that exponent to the front because that's a log property that you can do. And now we have gotten rid of our exponent. Beautiful. Then if you try doing infinity, you would get infinity times whatever this is. So 1 over infinity, that goes to 0 because 1 whole divided into infinity in many pieces goes so small, it goes to 0. So then you have 1 minus 0, ln of 1, that's just 0, so you have infinity times 0, which is indeterminate. So then you would want to rewrite this as a fraction, so it'll still be indeterminate, but if it's a fraction, 0 over 0 or negative or positive infinity over infinity, then we could do L'Hopital's rule, and it's going to make our problem easier to solve. So the key is anytime you see a variable next to something, you can always just rewrite that by dividing by the opposite of that something. Because let's think about it. To get rid of this, you would just multiply by n, gets rid of that, and then you would have to do it at the top too, and then you're just left with exactly what we had in the beginning. Now if you plug in infinity, again this goes to 0. ln of just 1 is 0, and then infinity goes to 0, so you have 0 over 0, and then you can do L'Hopital's rule. So we have that the log of our limit is going to be equal to the limit as it approaches infinity of the derivative of the top and then the derivative of the bottom. The derivative of ln of something is just 1 over that something. And because we're taking a derivative, we also have to do chain rule, so multiply by the derivative of the stuff on the inside. Derivative of this is just 0, and then we can rewrite this as n to the negative 2. There's already a minus there. That negative 2 goes outside, it becomes 2n. And then minus 1 becomes negative 3, so we have 2 over n to the 3. And then the derivative of this can be rewritten as this, goes out to the front, this is n, minus 1 is negative 2, negative 1 over n squared, because this just means bring it down. Now as soon as you do L'Hopital's, you want to simplify. So you want to get rid of this fraction. How do you do that? Well, you multiply everything by n squared, so that goes away, and then whatever you do to the bottom, you have to do to the top, so n squared. And multiplication is not distributive. You don't distribute the n squared to each. That's only when you're dealing with addition or subtraction, because you're just multiplying things. Just multiply them once. So I'm just going to go ahead and put that right here, and then this here just becomes negative, and then we can simplify further. The numerator is 2 times n squared, and it's negative, divided by this stuff right here. This is n cubed minus n cubed divided by n squared. It's n cubed minus just n. And remember, we're taking the limit as it approaches infinity of this, and this is the log of our limit. And now we have a really nice fraction with polynomials, a rational fraction, so we can divide every term by the term with the largest power in the denominator, which is this n cubed right here. So we would divide everything by n cubed. This just goes to 1, this goes to negative 2 over n, and then this goes to 1 over n squared. So now we have negative 2 over n over 1 minus 1 over n squared. And then if we plug in infinity, this is infinity, this is infinity. 1 whole divided into infinitely small pieces becomes infinitely smaller, so small it goes to 0, so this goes to 0. This also goes to 0, so we have 0 over 1, and that is just 0. But this is the log of our limit. We want our limit. So to get our limit, we have to get rid of the log. To get rid of the log, we do an inverse operation. What we do to one side, we have to do to both. So this cancels out. We're left with the limit being just e to the 0, which is just 1. And so because we found that the limit is equal to 1, we can say that this sequence converges to 1. And that's it for this video. I'll see you in the next.